Hi there! I thought maybe you were a little bit uneasy about finding determinants for 3 by 3 cases and also maybe a 4 by 4 case. So I'm back! Sorry, can't really see me that well, but good luck, okay? So we're going to use the method of minors and cofactors to calculate determinants for 3 by 3 cases. So I'm just going to show you this example using number 24 on page 596 of your pre-calc textbooks using minors and cofactors, okay? Here we get started. So we have this matrix here. It's a 3 by 3, 2, 1, 1, negative 1, 4, 0, 3, 4, 2, read by columns, okay? Now, so I want you to first think about, you're going to use minors and cofactors, so think about, okay, which row or column looks the easiest or looks good, right? Which one looks the easiest? Which one looks the best to you? And I think a lot of us are thinking any rows with ones is good, any columns with ones, or any rows with zeros is good, or any columns with zeros. So the one I like the most that I'm going to use is this guy here, 1, 0, 2, because there's no negative, there's a 1, there's a 2, and a 0, which means maybe not as many calculations. Let's do that together, okay? So I chose row 3, okay? So I'm going to choose row 3 to work with, okay? And we're going to use rows and minors and cofactors, not the 2-column extra method, okay? So let's move along. So how do I set this up? I'm going to calculate, let's call this matrix A, okay? So we're going to calculate the determinant of A. And we're choosing you row 3, So chose row 3. Remember, this guy is always plus, negative, plus. They alternate signs. Plus, negative, plus. So that means this guy 1, I leave it as 1. But I know that I have to calculate the determinant of every row or column that does not contain that 1. Okay? So I'm going to cover up every row and column. So what am I left with? Negative 1, 3, 4, 4. So negative 1, negative 1, 3, 4, 4. Can you see the pencil okay? I'll use a marker from now on, okay? Now, I'm going to go to my next value. So I already chose that. I'm going to go to the 0. If you want, you can write 0. Of course, it's minus 0, right? But it doesn't matter. Honestly, I wouldn't write the 0, okay? But I'm going to write it for this time purpose only. So every row or column, because this is plus, negative, plus. That means this guy has to be a negative, right? So that means every row or column, so I'm left with 2, 1, right? 2, 1, 3, 4. But of course, this is going to be eliminated, okay? Next one is going to be plus, plus, negative, plus. So again, plus 2, right? And every row or column that does not include the 2. So I'm going to go every row and column. So what am I left with? Negative 2, positive 2, negative 1, 1, 4. So I'm going to be left with 2, negative 1, 1, 4. So every row or column that does not include this 2 here, okay? So it's 2, negative 1, 1, 4. And remember, these straight lines, they indicate that you have to calculate the determinant, right? So I'm going to do that now. Equals 1. What's the determinant? It's negative 4 minus 12. 0, I'm just going to make that a 0, okay? I don't want to write that. Plus 2 times 8 plus 1, because it's 8 minus a negative 1. So what am I left with? It's 1, negative 16 here, plus 2 times 9. And I'm left with my determinant to be negative 16 plus 18, which is equal to 2. So that means the determinant of A, our matrix, was 2. Now, if you want, go ahead and check the solution with your calculators. Okay, all you do is press literally DET on your calculator, parentheses, and enter your matrix, okay? Okay. You could also try doing this with your extra 2 rows, right? So you can actually go positive 2, 1, 1, negative 1, 4, 0, 3, 4, 2, right? Remember this method? 2, 1, 1, write your first and second column. Oh, don't write that, okay? And then you remember how I could go multiply these products here, right? And then I can subtract out these products here. So you want to try that with me together? Let's try that, okay? 8 times 4 times 2 is 8 times 2 is 16, plus negative 4, right, and 0, minus 3, 4, 1, which is 12, 0, negative 2, okay? And I'm left here with 12 minus 10, which is also 2. So our determinants match up. Woo! Okay, so hopefully that cleared up for your determinant for a 3 by 3 using minors and cofactors. We're going to do one more. This one's a little bit trickier case. How about if you have a matrix that's not a 3 by 3, but how about a 4 by 4? I know, it's a little bit hard. I know your go-to is going to be using your calculator. And if we ever give you something like this, trust me, it's going to be super easy, or we're just not going to ever expect you to do that. Because, I mean, it's kind of a time-consuming technique, and we're more concerned that you know how to do the basic technique, okay? And now you have the tools to do it. So we're going to do this with number 28, page 596. And looks like I've already surveyed which row or column is the best for me. And I think the most friendly looks the second row. Don't you agree? Second row has lots of zeros. I like that. It looks easiest. Second row. Row 2 has been chosen. Now, this one's already done by me. I'm going to explain my process, okay? So I chose row 2 because it's got lots of zeros, okay? Let's move on. So I did this. So I said, okay, I chose row 2, right? Actually, I'll show you the whole question. Row 2, but I know that I have, so I'm going to write out, I'm going to blank out, I chose this element here, A21. That means it's positive in A11 always, so it's going to be a negative. So that's why I did negative, a minus negative 2. So minus a negative 2. Because it is a negative, and this is the original A21 element, okay? And I cover up every row and column that includes that row. So I eliminate every row or column that includes that, and I'm left with this matrix here. I'm left with this matrix here, in which I have to calculate the determinant later for, okay? And then let's go to 6. So it's going to be a negative, positive, negative. So I did minus and the original element here. And then whatever I cover up, 6, and the row that includes 6, I get this matrix here. Now, what do I do with this matrix? You're right. I know that you're like, what? I got to calculate the determinant of a 3 by 3? So I did it the long way here for you, but you're not going to be required to do this, okay? So let's go down. So that's the first part. You see this 2? That came from this negative of a negative 2. So that's 2. And I put a big bracket here because I chose this row here. I chose this guy here because it's got the most ones. So I chose third row, third row, third row, third row, and these 2 by 2 matrices are formed by, so these are the minors that are formed by covering up the row and column that includes a 3. So I did that for each of these, okay? And I got this. But of course, I'm going to continue, right? Because I have to do this matrix now. Now this matrix, it's obvious which row or column I'm going to use. So I put a negative 6 here. I put a negative 6 right here because I know that this was a negative 6 here. It looks like I chose this first column. I chose this first column, okay? I chose this first column because it's got a positive 3 and a positive 1 and a 0. So I have a positive 3 and I have all the minor. I have the minor here. Cofactor of negative 1 because it's positive here, negative here. And I'm left with 6, 4, 3, negative 1. And when I calculate the determinant of all those 2 by 2 matrices again, I get this whopping value here. Try to see if you can mimic that. Stop the video and see if you can match my answer. Stop the video and I do all this calculation and I got negative 108. Did you get negative 108? Okay, good luck. Bye.